In this video, I'm going to be showing you how to build out your own Perplexity style LLM answer engine completely from scratch. So we're going to be building the front end, we're going to be building the back end. I'm going to be showing you how to use all of the different technologies, such as the inference APIs. I'm going to be showing you how to use Reg. I'm going to be showing you how to use Langchain. I'm going to be showing you a number of different search engine APIs. We're going to be using the OpenAI embeddings API. There's just a ton packed into this. So it's going to be a little bit of a longer one than my typical videos. It's also going to be definitely more of a technical deep dive for this video. But if you're interested in seeing how I built this out, stay tuned. I'm going to go through exactly how to set this up, and I'll walk you through all of the different steps and my logic in why I set it up the way that I did. To get started with this, I'm going to put a link within the description of the video where you can go ahead and clone the repo. Now, there's a couple prerequisites to get started with this. You are obviously going to have Node.js installed. You're also going to have to fetch a number of different API keys. You can go ahead and get started for free with the Brave search API. Now, the reason I have two different search APIs is Brave gives you only one query per second. So within the example that I showed, we have the search results themselves, but then we also have images and videos. So I decided to use a second search engine API where I'm using a Serper. And the nice thing with Serper is you can try it out for free without even plugging in a credit card and get 2,500 free queries. Then we're going to hunt down an API key for OpenAI. We're going to be using OpenAI just for embeddings. You could also swap it out for a different embeddings model if you'd like. And then finally, we're going to get an API key from Groq. So if you head over to console.groq.com, click API keys, generate an API key. And then once we have all of that and you have it all cloned, we're going to head on over to the root of our project, and you can go ahead and npm install all of the different packages. So once you're all ready with your API keys, where we're going to actually put them is within a .env. So I have a .env.example here, and you're just going to put them in one by one. So you see we have OpenAI, Groq, Brave, and the Serper API. So once you have all of those plugged in here, we're going to be ready to dive into our application. The way that I'm going to set this up is we're going to go through the backend logic first. Then I'm going to hop over to the front end logic, and then I'm going to go through individually each different component that is rendered on the screen. The other thing that I don't think I mentioned is you will be able to deploy this to Vercel by the end of this. So if I just demonstrate this here and I say latest Sam Altman podcast with Lex. So you'll be able to put this on Vercel. You'll be able to interact with this there if you like. You can set up some authentication and do all of that. I'm not going to be doing that within this video, but you can just see how it works within the Vercel platform here. It's really easy to set up. So if you have the Vercel CLI set up, you'll be able to just go ahead and deploy it through your Vercel account for free. Or alternatively, if you just want to run this locally, you will be able to do that as well. Now, one question that I anticipate I'll likely get is, can I use Ollama with this? So you absolutely can. You can locally query Groq if you'd like. You can also query GPT-4 or a different model like Opus or whatever you want. But if you want to use Ollama, it's really simple. You'll be able to swap out the endpoint within the example. You'll be able to swap out the API key for Ollama, and then just changing out the string for the model ID for the different areas for the chat completion and a couple other spots. And you'll be able to set this up locally. So I tested that a little bit earlier. If you are an Ollama fan or just a fan of running things locally, just know that you'll be able to get the inference portion of this set up if you're interested in using a local model. So to get started with our backend, we're going to do everything within the backend, pretty much all within our actions. If you want to break this out so it's a little bit more modular, you can do that. To get started, what we're going to do within our action.tsx is we're going to first import a number of different dependencies. So I'm going to go into these a little bit as we go through all of the different code here. So the first thing that we're going to do is we're going to initialize the OpenAI client with the Groq API. The nice thing with the Groq API is it conforms to the OpenAI schema, so we will be able to query it just like we would the OpenAI API. Now, the nice thing with the OpenAI API standard is you will be able to swap it out, like I mentioned, for something like Ollama if you want. So if you want to use Ollama, you can just go ahead, swap this out for your local host, and then change the API key to, I think it's Ollama, and then, like I mentioned, change it within the chat completions and a couple other spots to get this all working locally. We're just going to set up some of the different interfaces for the different types that we're going to be using within our. For our first function, I'm just going to zoom in a little bit here, so hopefully you can see this a little bit better. I'll also close my sidebar a little bit, so hopefully you can see this. And what we're going to do is we're going to declare a function called getSources. Now, what this is going to do is we're going to take in the message as an argument, and then we're going to pass that message to the search engine API. Now, another thing that you can do, especially if you're sending in particularly long queries, you could pass in that initial query that a user is typing in within something that's going to optimize it for a search engine API. So you could very easily use something like an LLM as a rephraser and ask for a message back for a search engine API. I have that in a similar video, which I'll link within the description of the video, which you could use as an interim step here. Now, that would increase the time of this, but it will also prevent some edge cases where if you're passing in a particularly long query, it could potentially error out on the endpoint if you put in a really, really long message here. The way that this works is we're going to encode the message. We're going to specify that we're going to get 10 different results. From there, we're just going to parse the web response for a handful of different things that we're going to be using. So now that we've performed that search query and we've got those results from Brave, we're going to go ahead and go through those proverbial 10 blue links from Brave, and then we're going to go ahead and scrape each page. Now, one thing to note with this is I have a timeout of 800 milliseconds here. So if there's any pages that are taking a long time to respond, I don't want it to hang up here. I want it just to exit out and say, if it's taking longer than this, just don't use that result and return that back to me. The one thing to note with this is since we're just making a crude fetch request, if you notice that it's not fetching all of the results, you could also use something like Puppeteer here, but that's definitely going to increase your compute cost as well as the speed potentially on how quickly it's going to be able to run that query. But if you want more results, Puppeteer is certainly an option that you could explore here as an interim step within this function. So from there, we're just going to do a really crude extraction of all of the different main contents here. We're going to remove a bunch of different things that we don't need. So we don't need to take any inline styles or scripts or what's within the navigation or footer most likely. So we're just going to get rid of all that, and we're just going to get as much of just that raw text as possible. And then from there, we're just going to create a promise where we're going to concurrently go ahead and request all of those different options. And then we're going to have it extract all of the different page contents for us. And then finally, once it has those contents, it's going to return those back to us within the array like we have specified here. So once we have that, we're going to go ahead and process and vectorize the content using Langchain. So within this function, we're going to send in the query. We're going to specify the chunk size. So this is going to be something that you can play around with. I might even add a UI component on the front end where you can play around with this and explore different options of different chunk sizes or potentially different reg methods. I'll look into maybe adding in something like this. But this is just a basic reg implementation. So here we're going to have our chunk size of 1,000 characters. We're going to have a chunk overlap of 400 characters. We're going to be returning 4 similarity results. So these are going to be the default options. You could also call the function with different arguments if you'd like to swap some of these things out. So what we're going to be doing here is we're going to loop through all of those web pages that we just got. We're going to go ahead and split up the text with the recursive character text splitter from Langchain. We're going to go ahead, pass in our split up text. We're going to query that OpenAI embeddings API. And then we're also going to be setting up some metadata. And then finally, we're going to be performing a similarity search on the web page with the query with the number of different results that we want from that web page. So each web page is going to have a number of different results based on what you've specified here. So in this function, we're just going to go ahead and get the different images very similar to above. We're going to query the endpoint. You can use Brave, you can use Serper, you can use whatever you want within the responses here. And then what we're going to be also doing within this function is we're going to go ahead and actually fetch and query all of the different images to see that we actually get results back. So the reason I wanted to do this is when I was setting it up, I did notice that a number of the images wouldn't necessarily load. So I set up a little bit of a helper function just to make sure that we can get that request before we try and render it to the DOM and it shows a broken link. So within this function, you can use Serper, you can swap it out for Brave, you can really use whatever you'd like within here. From here, we're just going to be sending back the title and the link, so you could use the title for something like the alt tag if you'd like. And then I'm just going to slice it to 9 because that's what I have set up within the UI, but you could select a different number if you'd like. And then for using Serper, so this is how you'd use the query for Serper. So if you want to use the Serper images API, you can just go ahead, put this above within the query. So if you want to use Serper for both images and video, you can just easily swap this out for the above, and vice versa. If you say you just want to use Brave, you could use that within the videos option here. So very similar here. We're going to also check to see that the result of the image is successful for what we're going to try and render to the DOM. And then similarly, we're just going to be sending those 9 results back. Once we have that set up, we're going to be using a new feature that's within the Groq endpoint just as of last week, which is the JSON mode. So if you specify that you want the response format within the type of JSON object, you can go ahead and pass in a system message just like this with a message of what you'd like to send in here. So here are the top results from a similarity search. I'm going to JSON stringify all of those different results. And based on those results, I'm going to be getting the follow-up questions that we're going to see at the end of the application there. Next, we're going to be declaring the main action function. So this is going to be really what orchestrates all of the above functions, as well as actually streaming those different results to the front end. Within here, we're going to set up a new create streamable value. What the create streamable value allows us to do is it allows us to send that JSON as it comes through right to the front end here. And you'll see that in just a moment here. So once we have that declared, we're going to set up an asynchronous function. We're going to log out the user message when it comes through. So we're going to be setting up a promise for get images, sources, and videos. And then what we're going to be doing is once that resolves, we're going to be sending all of those to the front end. So you're going to have that effect where they all render in at the same time. And you're not waiting for all of these different results one by one for it to load. You're going to go ahead and make all those requests concurrently. And then similarly, it's going to concurrently send all of those back to the front end once they've resolved. Since we have our sources now, we're going to go ahead and take these sources, which are all of those different results that we got from Brave. We're going to be passing those within our get 10 blue links function. And then what we're going to be doing with those different results is we're going to be passing that within our process and vectorize content function. That's going to return the vector results. And once we have that, this is going to be where we declare our streaming chat completion. Within the system message here, I see a little bit of formatting that I'll clean up once I push the repo here, but the system message is here is my query. We're going to send in that user message. We're going to respond back with an answer that is as long as possible. I wanted to do that just to really demonstrate the LPU speed from the Groq inference chips because they're super fast and it's sort of neat just to see how many tokens it can generate just as quickly as it does. Then I'm going to say, if you can't find any results, respond with no relevant results found. And the user message is going to be, here are the top results from a similarity search. And then we're going to JSON stringify all of those vector results. This is going to be all of those top results with the metadata. And we're going to send that in and we're going to wait for our response here. Now, the cool thing with this Vercel AI SDK and leveraging that create streamable value API is we'll be able to iteratively go through the stream as they come in and just send them right to the front end. So it did take a little bit of a while to figure out how I wanted to manage state and all of that. But once I had that figured out, it's pretty powerful what you can do with this. So kudos to the team at Vercel. They really did a great job with implementing this new Vercel AI SDK. I've had a lot of fun playing around with it. From there, we're going to go ahead. We're going to generate those relevant questions. So this is going to be where we have that JSON mode within Groq, and we're going to ask it to respond in that particular schema that we asked for. We're going to pass in those results that we had here, and we're going to be asking it to generate follow-up questions. Then we're going to stream those out once they come in. You can also stream other things. You can stream all sorts of stuff. You can also stream out UI, so full components if you'd like. From the back end, there's a ton of different stuff. I'll be covering it within more videos, likely within the future with this new Vercel AI SDK. But this is just something I'm going to clean up within the repo once I push this live. Then the other thing to note is you do have to make sure that you do call done once it's all done. You will get errors in your console if you're just updating and you never actually call that done function. So then from there, we're just going to return that streamable value. And then we're going to define our initial AI state and UI state, just like we see here. So once you have that, that's pretty much it for our back end here. I'm just going to go ahead, make a quick git add, git commit, update actions. I'm going to push that to the repo here. So for the front end of our application, we're going to be importing a number of different dependencies here. But then the main part that I want to call out here are these are all of our custom components here. If you want to go ahead, play around with the different components that I've set up here, if you want to add in different effects or different functionality, you can go ahead within these components and you should be able to play around with these components pretty safely without affecting other portions of your application. Similar to our backend, we're going to be setting up a number of different interfaces here for all of the different types that we're going to be using. Then what we're going to do is we're going to set everything within our page here. What we're going to be setting up is the My Actions, which is again from the Vercel AI SDK. So this is going to be how it interacts with that Actions TSX within the backend of our server. Then what we're going to be setting up is a number of different things for our form submission handling. So on key down, on enter, on all of those different things, we're going to have that state for the actual input itself. All of that good stuff is here. Then from there, what we're going to be doing is we're going to have a simple state for all of our messages. So the state that I chose to set up our application for the most part is all within this messages array. Within each result, we're going to have an array item of an object. We're going to have the follow-up within there. We're going to have images within there, videos within there, the sources. And then once the actual LLM response is complete, we're also going to put in that within this messages state as well. But while we're streaming out those responses from the LLM to the front end, we're going to have an interim state, which is the current LLM response, which is what you see here. So then what we're going to do is we're going to set up a handler for when the user clicks the follow-up button. Because originally when I was setting this up, it was just set up on that initial form input, but I wanted to set it up when you click the follow-up questions. So just to make it work on both when you're typing in the input or when you're clicking at those follow-up questions. That's why we have it broken out a little bit here. And the next, we're going to have a simple use effect that's going to be called whenever the input ref gets changed. So on key down is going to be looking for all of those different changes on the input to be able to set the state for what the input is. We're going to have a few different functions for handling our form submission as well as clicking on those follow-up questions. Then next, what we're going to set up is the handle user message submission. So here we're going to create a unique key, which we're going to pass within the props of each of our components when we iterate through them. So it has something unique. We're going to be setting the date for all of those. So it doesn't cause multiple re-renders. We're going to put that key on each component. So this is going to be what that message object looks like. So we're going to have the ID, the type, the user message, content, images, videos, follow-up, whether it's streaming or not, as well as the search results. Once we have that, we're going to set the message, and then this is going to be where we're going to be awaiting all of those different asynchronous results from our action. So this is going to be where we call the action. So as those different responses come back from the backend, we're going to be able to read those as a stream. And then as we're reading through them, this is going to be how we go ahead, going to be where we orchestrate where all of those different values go within the front end of our application. So as that readable stream comes in from the back end, we're just going to set up a loop where we're going to be waiting for all of those different results. And then this is going to be sort of what orchestrates on as those things come back from our React server component and they get streamed back from our back end. This is going to be what delegates where in the different spots of the states the different things go. So if it's images, we're going to put it on the images key. If it's videos, we're going to put it on the videos key, etc. Then from there, we're going to set the current LLM response. And then from there, we're just going to really render out our view here. So you see, we pretty much have everything within our messages loop here, which I'll just go into in just a moment here. And then the bottom half of it is going to be just everything for our simple form submission here. So once we have all that, we basically have three pieces that we're going to be returning here. We have the messages array, which I'll go into just a moment. We have a chat scroll anchor. This is going to be how it scrolls to the bottom as the messages come through. And then we also have the input itself. This is going to be the text area where we actually put in the message and where it has the button to submit and all of that stuff. But the main portion is going to be within this messages array. And then as they come through, if they exist, we're going to render them within these sequential chunks here. So that's something that as I was setting this up, I realized where we really had to set up state in a way where it made sense to sort of group all of these things in, but we also had to be mindful that certain values are going to be streaming in, they could be updated potentially multiple times, and all of that stuff. So here, this is going to be where we see we have the key for our different components here that's set up. So you have the search results up top, then from there you have the user message, so what you've actually submitted. Then you have the LLM response component. So you're going to see whether it's a current LLM response, and that's going to be streaming in from the component. Or once that's done, it's going to set that LLM response as that historic state. Then we have the follow-up messages that's going to appear below this once it comes through. And then finally on that sidebar there, we have the videos and images, which you can render. And you will notice that each of these do have the key. These are important just so it doesn't cause multiple re-renders. And it has these keys, which is how React knows not to sort of excessively render all of these different components since it is within a loop and all of that stuff. So you can also look into memoizing different components if you'd like. Now, those are the main pieces of the application. The way that I set this up is for all of the custom components that I've set up in the application are all within the components folder and then within the answers directory here. So you can go ahead, check them all out. There's essentially a different component for all of those different core elements of what you see on the screen here. So we have the search results component. We have the user message, which is the simplest component because it's just going to show what you submitted. It's going to show a couple logos. We're going to have the images component. I set these up in a way where they're varying in complexity. So if you're new to React or Next, I'd take a look at the user component, try and play around with it. If you're looking for something that's more adventurous, check out the videos component. This is going to be how we actually get those videos, and we show that iframe in the corner there, where you'll be able to have those embedded videos that are sort of floating absolutely within your application. And yeah, I encourage you, play around with this. If you have any ideas for the application, put them within a comment of the video here, put them on GitHub, send me a message on Twitter, do whatever you like to do. But that's pretty much it for this video. I hope you found this video useful. I had an absolute blast building out this application. I'm going to be setting that up with a very permissive license, so you'll be able to take this, go ahead and build a business with it, do whatever you want with it. Hopefully you learned something. If you found this video useful, please like, comment, share, and subscribe. Consider becoming a Patreon subscriber or a subscriber on YouTube, or support me in whatever way you'd like. Even a GitHub star would be great. Let me know what you'd like to see in any upcoming content within a comment below. You know where to find me. Until the next one.